So in the last example, I showed you that you didn't necessarily have to complete the square to find the coordinates of the vertex. However, this time I am going to use completing of squares to find out where that vertex is, and then we're going to interpret that those results. So let's read the question here. Two numbers have a sum of 20. So I can write it down: x plus some other number equals 20. Not 120, simply 20. Does the sum of their squares have a minimum or maximum? Determine the minimum or maximum and the numbers. So what I'm going to do is I'm going to do the exact same thing as I did with my previous question, with my lengths and my widths. Now you don't want to say you don't want to have three variables. You just want to have two variables. And if I said let a equal a number and let x equal a number and let y equal the sum of their squares, then I would have something that looks like y equals x squared plus a squared. And I have an equation here now with three variables. So what I'm going to do is I'm going to say let x equal a number and let y equal the sum of two numbers squares. So it doesn't quite make sense here now. The sum of two numbers squares. And I'm going to set I'm going to create an expression that relates x to 20 and a. So my two numbers are going to be x, and I'm going to isolate this a, so I'm going to subtract x from both sides, and 20 minus x. Because if I add x and 20 minus x, I simply get 20, so that's good. So y equals the sum of their squares. So I know that I'm adding things together. I'm going to say x squared plus 20 minus x squared. And now what I'm going to do is I'm going to expand this out, and then I'm going to complete the square. So if I can write my steps here: expand and complete square. Now where this is different from the last question is that this is not in factored form, so I can't pull out where the x intercepts are very easily by setting this equal to 0. The one that is up here, I say a equals L times, so two factors multiplying with each other. But this one that we have here, just in comparison, I say x squared plus this. So I need to expand this out and then complete the square. So then y equals x squared. And I'm just going to do this the long way, though I don't need to necessarily, but it's maybe helpful for some people to step it out. Y equals x squared plus 400 minus 20x minus 20x plus x squared. Y equals x squared plus 400 minus 40x plus x squared. Now I have these two like terms, so y equals 2x squared minus 40x minus 400. Now what I could have done here, just as a side, I'm going to write this in red because you don't need to write this down. I can simply go 20 minus x squared by saying 20 squared, 400 minus 2 times this number, so minus 40x plus x squared. I didn't have to expand it out slowly like that. I could just quickly have done it. I could have gone from this step to this step and eliminated these 2 steps. But if you wanted to take the few extra steps to step it out like that, I'm fine with that. It'll just slow you down just a little bit. So now what I want to do is I want to complete, oh, actually, the question says right here, does the sum of their squares have a minimum or a maximum? We can actually go through right now and answer that question by looking at this. The coefficient in front of the x squared term is positive. So the parabola opens upwards. So this quadratic has a minimum. Because when I draw it like this, I know that it opens up. So we're going to have a minimum point. Now what I want to do is I want to do step 3, I think. Let's see. Yeah, step 3, completing the square. Y equals, oh, I'm just going to highlight this in pink as well because that's the answer to this part. Just so you know where everything's coming from. So then 2, factor out that 2, x squared minus 20x. And I need to think of 2 numbers that, well, one number that I can both add and subtract. If I want to do some work off to the side here, I can say it's going to be b over 2 squared. Our b is negative 20 divided by 2 squared, which is negative 10 squared, which is 100. So I'm going to both add and subtract 100 plus 100 minus 100 minus 400. So what I need to do now is I need to take this negative 100 and outside of the bracket so that I can factor this into factor this perfect square trinomial. So 2 times x squared minus 20x plus 100. 2 times negative 100 is negative 200 minus 400. Y equals 2 times x minus 10 squared, because that's the factored form of this, minus 600. Oh my word, did you guys notice a mistake? I hope you did. So I want you to just fix a few things for me. It's actually supposed to be positive 400, not minus 400. So I need to go through and make sure that I have positive 400 for everything. So then that changes this a little bit. Negative 200 plus 400 is going to be positive 200. So remember, I just changed this to positive, this one to positive, and this one to positive. Okay, so we've completed the square. Let's interpret this. The question itself asks us, determine where the minimum or maximum is. And we found out that it's going to be a minimum. So the minimum of the sum of their squares happens to equal, or the sum of the squares is equal to 200. And the 2 numbers come from here. Oh. And the 2 numbers are x and 20, 20 minus x. But we know that x equals 10. So x equals 10. And the second number is going to be 20 minus 10, which equals 10. So the minimum happens at 200 and the two numbers are 10. So let's go off to the side and do some rough work. The sum of their squares, 10 squared plus 10 squared, does that equal 200? Well, 10 squared is 100 and 10 squared is 100, so that equals 200. Excellent. So we can see that the two match up, so our answer makes sense.